Hi, my name is Sita Sissa, and I'm a graduate student in the Ecology Department at UC Santa Barbara. The focus of my studies is on how climate change is affecting ecosystems in the Arctic, and this picture is a picture of our group working up in Greenland, trying to understand this in the soil. Unfortunately, I can't take you with me to Greenland or to Alaska, where my work is focused, but this winter, for the School of Scientific Thought, I'd like to introduce you to how to understand climate change from a molecular to an ecosystem perspective. Understanding a changing world requires understanding from the molecular scale to the ecosystem to the global scale. So in this course, we'll walk through figuring out how we know that this molecule, which is more commonly known as CO2 or carbon dioxide, which is a colorless, odorless gas in our atmosphere, is increasing. So most of you probably weren't born in 1958 when this graph starts, but most of you probably were born by the 1990s. And within your own lifetime and my own lifetime, which is 10 years earlier, the CO2 concentration has been increasing in our atmosphere at an unprecedented rate. This class will go over how we know that CO2 is increasing. How do we measure this molecule that we can't smell or see? How do we know that it's increasing, and why do we think that's important? We'll go through the history of this because, believe it or not, people knew since the 1800s that CO2 might cause a climate change effect, but they were discredited. People thought they were a little crazy. And we'll go through why people changed their perspective on increasing CO2 having an effect on our climate. So we'll walk through that. How do we know this graph? How do we know that globally carbon dioxide is increasing? And why do we think now, 100 years after the effect was first discovered, that increasing CO2 is going to change our global climate? This graph shows what a bunch of scientists and researchers, when they came together and tried to figure out from 1990 to 2100, so about 90 years in the future, how people's actions globally might impact the temperature of the Earth depending on how people behave. So if populations rise, but technological innovation slows, we'll have one projection for how warm the Earth will get. If population stops growing, human population, and we get clean technology, we have another scenario. And these are really big differences in global temperature. So how do we get these predictions? How do we go from knowing that CO2 is increasing in the atmosphere to what 100 years in the future our Earth might look like? So we'll use this class to go over how you go from this graph to these graphs. Understanding a changing world will move through scales. We'll go from understanding how increasing carbon dioxide is being used to how our knowledge of increasing carbon dioxide is being used to project future climate change, and how we know that this increasing carbon dioxide is being driven by people's activities. There's a lot of global warming skepticism. People who say that climate change is a natural phenomenon, that the Earth's climate naturally changes, and it does naturally change. But how do we know for certain, unambiguously, that this increase in CO2 is caused by people's activities and not natural changes? We'll go through that in the class. We all drive to work or to school. We all plug in cell phone chargers, turn on computers, take a hot shower. All of these different things, including the foods we eat, including the foods we eat, the lives we live, have costs associated with them, energetic costs, and these costs ultimately have a carbon cost to it. But how do we calculate that? How do we move from one person driving down the street to the energy cost that the population as a whole is creating? The last part of our course will go over a new trend, which is carbon calculators for individuals to understand their own carbon budgets, where they're getting their numbers from, how good they are, and how you can use them in your own lives to reduce your own carbon costs and those of your friends and family. So really, understanding a changing world comes down to energy and ecosystems. How much energy we use, where is it moving, and how is it affecting our ecosystems, our biomes, our climate, and our whole globe. This comes down to two equally important perspectives. The first is the numbers. The numbers deal with complex data sets with very big numbers relating energy consumption to climate change. And we'll go through from the big data sets to the individual molecules. Where do they get these numbers from? How good are they? This is going to involve your biology, your physics and chemistry. It also involves history and environmental science, economics, and sociology. So basically, any courses or reading you've done in your high school courses, those will probably come into play in this course. The second is human actions. How does your lifestyle impact the climate system? And the goal of this course overall is to bridge the science that quantifies and describes climate change with the way that we live our lives now. So I hope you'll join me in understanding a changing world from molecules to ecosystems. And thank you very much.